Let's start from the section on scaling in practice and seamlessly transition into explaining the code. Scaling in practice. When to scale. Always scale features before training models that are sensitive to feature scaling. This ensures that all features contribute equally and that the model learns effectively. Consider scaling features when exploring data, especially during visualization. Proper scaling allows for clearer insights and better interpretations of data patterns. Common libraries. Scikit-learn offers several handy tools for scaling. Min-max scaler rescales features to a range of 0 to 1. Standard scaler centers features around 0, adjusting based on the standard deviation. Robust scaler uses statistics that are robust to outliers. Now let's dive into a practical code example to see how scaling works. Code example explanation. Importing libraries. First, we start by importing the necessary libraries. We use pandas for handling our data and scikit-learn for scaling methods. Import pandas as PD. From sklearn.preprocessing import min-max scaler, standard scaler, creating a sample dataset. Next, we create a simple dataset with two features. Let's call them feature 1 and feature 2. In this dataset, feature 1 has values ranging from 10 to 50, while feature 2 has much larger values ranging from 1000 to 5000. Applying min-max scaling. We then create an instance of min-max scaler. This scaler will transform our feature values to a range between 0 and 1. Using fit_transform, the scaler learns from our data and rescales it. Now when we print normalized_data, we'll see all values scaled between 0 and 1. Applying standardization. After that, we create an instance of standard scaler. This scaler will center our features around a mean of 0 and adjust them based on the standard deviation. Again, with fit_transform, we get a new dataset that is standardized. When we print standardized_data, we'll see how the values can be positive or negative centered around 0. Viewing the results. Finally, we print both the normalized and standardized results. This step allows us to clearly see how each scaling method has transformed the original data. By following these steps in our code, we effectively prepare our data for machine learning models, ensuring they perform optimally. Scaling features properly is a key aspect of data preparation that greatly influences model performance. Thank you for watching, and I hope this explanation helps make scaling in practice clearer. If you have any questions or want to explore further, feel free to reach out.